We're going to look at Lab 13 today. So Lab 13 data sheet, Making Solutions, has been provided to you in a different link. So I have filled in some of the spots that are filled in on your data sheet. Hopefully I have the right information this time. So I'm just going to go through filling a few of these as examples and then leave you to fill the rest. So I'm starting with part A. There are two parts. So part A is a liquid solution. So if you were in lab, what you would have seen is me take a volumetric flask, which looks something like this, and make a solution. So what volumetric flasks are, they're a very accurate measurement to make solutions. So these flasks are specifically made to a certain volume. So for instance, we have a 50 milliliter volumetric flask, we have 10 milliliter volumetric flasks, and what that means is, in this particular one, we're using a 10 milliliter one. So when we fill it, this volumetric flask, up to the line provided, that means there's exactly 10 mils in here. Okay, so it's almost more accurate than a graduated cylinder, which is what we usually use to measure our liquids. So that's why we use them to make or to prepare solutions, is because of their accuracy. So what we're looking at today is, in this volumetric flask, we're making an acetone water solution. So we first put some acetone in this flask and take the mass. So that's where the mass of the flask and the acetone comes from. Then we fill that flask up till it's to the 10 mil mark with water. And then we mass it again, which gives us the mass of the flask, the mass of the acetone, and the water together. Okay, so we're going to use these masses along with the mass of the flask when it was empty and dry by itself to figure out how much acetone exactly that we added, because we didn't weigh it out, we didn't use a graduated cylinder, so we need to figure out the mass of just the acetone by subtracting. We're also going to figure out the mass of the solution by subtraction. So let's look at exactly how we're going to do that. So this lab is really just focusing on, first of all, the definition of a solution, which I'm going to write down here. So what a solution is it's made up of a solute and a solvent. So we need to figure out what is the solute and what is the solvent. So the solution as a whole, the entire solution, is made up of acetone and water. So which one is the solute and which one is the solvent? Well, by definition, solute is the one in lesser amount, and it's usually the one that has been dissolved in a substance. Okay, so to figure out which one's in lesser amount, let's do these subtractions. So if we want to figure out the mass of acetone, well, let's see here. We have the mass of an empty flask, empty dry, and then here at 35 grams, we have a mass of the flask with the acetone in it. So what are we going to do with these two numbers? Subtract them. So if we subtract them, we're taking the flask with the acetone and we're subtracting out the flask so that we'll have just the acetone left. So we're going to take 893, subtract from 34.0, I don't know why I drew a line in there, 63. 35.893 minus 4.063. And I get 1.830. So why did I add a 0 on the end of that? If you remember, with significant figures, when we're subtracting, we're looking at decimal places only. And we have 3 decimal places in both these numbers, so I want 3 decimal places in my answer. So I have 1.830 grams of acetone. All right, now let's figure out how much water I have so that I can figure out which of the two is the solute and which one is the solvent. Because I'm going to need to know and label correctly for when I do the concentration calculations over here. Okay, so this next number, the 43, that's the flask with the acetone and the water. Okay, so if I subtract out the flask, what will I have left? So let me show. If I take this 43.365 grams and say I subtract out just the flask, what's left? What's going to be left is the acetone in the water. And the acetone in the water, that's the solute and the solvent. So if I subtract out the flask, I'm left with the solution. Okay, so that's this mass here. So the mass of solution is going to be the acetone and the water together. So to figure out the acetone and the water together, I'm subtracting out the empty flask. 4.063. And I get 9.302. Okay. So I have my solution. Well, how do you think I get just water by itself? Well, I have the equation down here, right? Solution is equal to solute plus solvent. So I know what my solution is. It is 9.302. So let me just plug in those numbers. 9.302. That's my solution. That's going to equal to solute plus solvent. Okay, well I'm trying to figure out what those are, but I know that one of those is going to be the acetone because the total solution is made up of acetone and water. So if I know one of the two, I can figure out the other one. So how am I going to figure out the other one? Well, look at this question mark as an X and solve for X. So to figure out X, since I'm adding, to get rid of this 1.830, I need to do the opposite operation. What's the opposite of addition? Subtraction. So if I subtract 1.830, I get 0, right? Whatever I do to one side, I have to do to the other. And this is going to give me X by itself. So taking 9.302 minus 1.830, I get an X with 7.472. And the units on it are going to be grams. So this is the water. So another way of looking at this, we're doing the wrong thing here, is our solution in this case is made up of acetone and water. And what we did is we took the solution and subtracted away the acetone to figure out what the water was. Okay, the solution, we subtracted out the acetone to figure out water. And you can even prove that to yourself. If you add the acetone and the water together, they should equal the total mass of the solution. All right, so we have our table filled out. We're using these numbers to fill out the rest of the table, and the rest of the table is really just calculations. Okay, so I'm going to erase these here. And I'm not going to do all the calculations, but I do want to at least show the first one, because that's usually the one that most people find difficulty with, and that is the molarity, because it has a lot of steps. And for molarity, it's moles of solute over liters of solution. Okay, well, solute solution. We need to know which one is the solute. Is it the acetone or the water? Well, we said solute was the one in lesser amount. Looking at these values, so here's the acetone, here's the water. These two amounts is what's making up the solution. So which one's smaller? The acetone's smaller. So the acetone's the solute. Okay, so the 1.83 grams, that's what we're going to use to figure out the moles of solute. And on the bottom, we need liters of solution. Okay, so if we need liters of solution, what part of the table is going to help us figure that out? So solution is both together. All right, well, we do have mass of solution, but it would be much easier to figure out using the volume of solution. So I'm going to take this volume of solution, and that is what's going to help me get to the liters. So these two pieces I'm going to use to figure out what I need in that molarity equation. So let's start with moles of solute. Okay, well, I have grams of solute. I don't want grams, so I'm going to need to get it in moles somehow. So how do we go from grams to moles? We use molar mass. Okay, so first step is to figure out what's the molar mass of acetone. Well, in order to figure out the molar mass, we need the chemical formula, and I'll give you that here. C3H6O. So you want to write your list of each element present, the number of each based off of the subscripts, and then you'll go to your periodic table and find the masses. Multiply across and add them all together. I still haven't learned to do this beforehand. I get 58.08. And what are the units on molar mass? Grams per mole. That's what allows us to go between grams and moles. So I'm going to use that to do a conversion. Let me erase this down here and we can do our railroad tracks right here. So let's get my railroad tracks ready. What do I want to put in the upper left-hand corner? What am I starting with? So this is my conversion factor here, so I don't want to start with the 58. What I want to start with is my grams of solute. And my grams of solute is this acetone here. So that's 1.830 grams. And then you're going to take my molar mass, making sure to put the gram portion on the bottom. And the molar portion can go on top. So I will take 1.83, divide it by 58.08. And I get 0.03, how many sig figs are we looking at? 4? 1, 5, I'm going to round up to a 1. So my grams canceled, so the units on this is moles. More specifically, moles of solute. So this piece of information, the moles of the solute, is going to go in the numerator. So I'm going to copy that up here now. So I have one piece of information to calculate my molarity. Now let's figure out the liters of solution. Okay, so for liters of solution, liter being a volume, so we're going to use the volume of solution, 10 mils. So when we filled up that volumetric flask, it was a 10 mil volumetric flask. So we know there was exactly 10.0 milliliters in it. So let me make some room here. We have milliliters, and we want to get to liters, so we can plug it in up here. Move this down a little bit. All right, so let's write the number. We have 10.0. Let's get our scale ready. Since it's metric to metric, they have that L, that liter in common. We can use the KHD space DCM, King Henry died drinking chocolate milk. And in this case, what's going to go in that empty space? It's volume, so we're going to put an L for liters. We are at milliliters. Okay, that's where we're going to start, the little m over here. We want to get to liters, the middle guy. So we're going to move this decimal 1, 2, 3 times, and I move to the left. So I'm going to start at the decimal and do the same thing, 3 times to the left. So 1, 2, and 3. So I get 1 empty space. In that empty space, I'm going to put a 0. So keeping the decimal there, 10 milliliters becomes 0.010 liters of solution, total solution. That means water with the acetone in it. So I'm going to bring that up here, plug it into my equation, and solve. So I have my moles of solute, my moles of acetone on top. And I'm dividing that by my liters of solution, which is the acetone and the water mixed together. So the molarity of the solution, the concentration, is 3 point, we're still looking at 4 sig figs, I think. Nope, just 3 sig figs, because we used that number. So 1, 5. And then capital M are the units on molarity. So this, you need to show the calculations as well. That's why there's space at the bottom. But this is the solution, or the answer, I should say, for molarity of solution. You'll notice you have to figure out the concentration in a few other ways as well. I'm not going to work through those in whole, but I am going to show you the equations for them here. Just because they're written in words where we have seen them with symbols. So where it says percent by mass, they're talking about percent, this percent mm that we have in our equation sheet. So this is percent by mass. So that is grams of solute over grams of solution. And you're going to multiply that by 100 because it is a percent. So grams of solute, we said the solute was acetone, so you can guess that we're looking at mass of acetone, that 1.830. For the denominator, the grams of solution, so this time we're not using the volume, we're going all the way down here where mass of solution is. And that's that 9.302 that we figured out. That's what we're going to want to put in the denominator. And then multiply by 100. So nothing tricky on this one. We're just picking the correct pieces of information and plugging it in. There's no conversions or anything necessary. For percent by volume, it's similar, except for it's MV. So we still have the grams of solute, the grams of the acetone on the top, but instead of grams of solution on the bottom, we're going to use milliliters of solution. So the volume of solution from that volumetric flask is already in milliliters, so we don't need to convert. Don't forget to multiply by 100 to get it in a percent. And then the last one is density. So we haven't done density in a while, but density is going to be mass of solute, because it's grams per mil. So I should say grams instead of mass. Sorry, I'm used to saying mass over volume. So grams of solute over milliliters of solution. So I guess the only difference between these two is that this is a percent that you're multiplying by 100, and this one you don't multiply by 100. All right, so make sure you are doing these last three on part A and filling in the calculations. And then you're going to go to part B, which is very similar, but instead of a liquid solution, it is a solid solution. So we're taking sodium chloride, NaCl, and dissolving it in water to make a solution. Okay, so sodium chloride is going to be your solute. The water is going to be your solvent, much like the water was the solvent in this liquid solution. And you're going to do the same types of calculations. Okay, the subtractions to fill in the blanks, on the table, and then molarity, percent by mass, density, and then also concentration in ppm. So ppm, you'll remember, is very similar to this equation, but instead of multiplying by 100, you're multiplying by 1,000,000, because ppm means parts per million. I'll even write that down here as a closer to this video. So it's grams of solute over grams of solution. Since it's parts per million, instead of times 100, you're doing times 10 to the 6th, or times 1,000,000. All right. Last lab of the semester. So good luck. Let me know if you have any questions.